Have you ever stopped to think about how much artificial intelligence has evolved in recent years? In the past, it was something restricted to laboratories, to huge and expensive computers, far from our daily lives. Today, it is increasingly present, from the moment we wake up until we go to sleep, whether in virtual assistants, photo apps, automatic translators, or even movie and music recommendation systems. But even with all this evolution, there was a dream that seemed distant. To have a truly powerful, multimodal AI running natively on your own smartphone, without relying on external servers or fast internet connections. It was in this context that Google's Gemma project emerged. The goal was bold and, for many, almost impossible: to create an AI model capable of processing text, images, and audio, all in real time, directly on the user's device, even if it was a simple phone with just 2 GB of RAM. To understand the size of this challenge, just remember that the most advanced AI models in the past required dozens of gigabytes of memory, something unthinkable for most mobile devices. Over the years, Google's team of engineers and researchers delved into this problem. They knew that if they could overcome this barrier, they could democratize access to artificial intelligence, bringing cutting-edge technology to billions of people around the world. The path, however, would not be easy. It was necessary to rethink the entire architecture of the models, seek new forms of optimization, and, above all, innovate in how AI manages and uses its own resources. The real turning point came with the creation of per-layer embeddings, or PLE. This technology, developed in partnership with DeepMind, completely changed the game. Instead of keeping all the model's parameters loaded in memory all the time, PLE allows only the necessary parts to be activated as needed. It's as if there were several specialists inside your phone, ready to spring into action, but each one only appears when really needed. This not only drastically reduces memory consumption, but also increases efficiency and response speed. Another fundamental advance was the adoption of the matte-former architecture, inspired by the traditional Russian dolls, the matryoshkas. Inside the main model, there are smaller versions that can be activated according to the complexity of the task. If the user asks a simple question, only the lean core is used, saving energy and speeding up processing. For more complex tasks, the larger model comes into play, ensuring precision and richness of detail. This flexibility is what allows Gemma 3N to function smoothly, even on devices with limited hardware. But the real revolution lies in multimodality. Gemma 3N is not limited to understanding text. It can analyze images, recognize sounds, and soon even process videos, all within a 32,000 token context window. To handle images, the model uses a SIGLIP encoder with 400 million parameters, which transforms each image into 256 visual tokens. These tokens are then processed along with the text, enabling complex analyses such as describing the content of a photo, identifying objects, or even extracting information from scanned documents. In the case of audio, Gemma 3N converts each second of sound into multiple tokens, allowing not only speech recognition, but also emotion analysis, noise identification, and even automatic transcription of conversations. All this happens locally, without the data needing to be sent to the cloud, which ensures more privacy and security for the user. These capabilities open up a huge range of possibilities. Imagine a student who needs to translate a passage from a book. Just take a photo of the page and ask Gemma 3N to translate it. Or a visually impaired person who can use the phone to describe the environment around them, identify obstacles, or read signs. Marketing professionals can create multimedia posts in seconds, combining text, image, and audio in a creative and efficient way. And the most impressive part, all this runs on devices with just 2 GB of RAM. For comparison, previous models required up to 70 GB of memory for computer vision tasks. With Gemma 3N, the same type of processing happens in real time, without crashes or slowdowns, thanks to the combination of PLE, matformer, and advanced quantization techniques that further reduce resource usage. The democratization of artificial intelligence is perhaps Gemma 3N's greatest legacy. By allowing anyone, anywhere in the world, to have access to powerful AI in their own pocket, Google is paving the way for a new wave of innovation. In remote regions where internet connectivity is unstable or non-existent, students, teachers, entrepreneurs, and healthcare professionals can rely on smart tools to learn, teach, create, and solve everyday problems. In education, for example, Gemma 3N can be a valuable ally. Teachers can create personalized content, correct essays, suggest activities, and even adapt teaching to each student's pace. Students gain an intelligent tutor, capable of answering questions, explaining concepts, and helping organize their studies, all without depending on a constant connection, ensuring autonomy and privacy. In healthcare, AI can assist in the preliminary diagnosis of symptoms, provide first aid guidance, remind medication schedules, and even facilitate communication between patients and professionals, especially in isolated communities. For people with disabilities, the possibilities are even greater. Screen reading, environment description, real-time translation, and enhanced accessibility in apps and services. In the business world, small companies can automate customer service, create personalized marketing campaigns, analyze sales data, and even generate detailed reports, all with the help of Gemma 3N. Large companies, in turn, can integrate AI into their apps, offering advanced features to millions of users without overloading servers or increasing infrastructure costs. And the impact goes beyond individual use. By running locally, Gemma 3N reduces the need to send sensitive data to external servers, increasing privacy and information security. This is especially important in times of growing concern about the use and leakage of personal data. Moreover, by saving energy and computational resources, the model contributes to sustainability, reducing energy consumption and the carbon footprint associated with massive use of cloud servers. The launch of Gemma 3N marks the beginning of a new era, an era in which artificial intelligence is within everyone's reach, ready to turn ideas into reality, make everyday life easier, and open doors to previously unimaginable opportunities. If AI was once a privilege for a few, now it fits in your pocket, ready to be used anytime, anywhere. The future has arrived, and it is multimodal, efficient, accessible, and secure. With Gemma 3N, the only limit is your imagination. Whether to learn, create, work, or connect with the world, artificial intelligence is closer than ever, ready to help you go further. If you're curious to experience this revolution, know that it's already possible to create videos, content, and innovative projects using the power of Gemma 3N. Platforms like videogen.io allow anyone to produce professional videos, combining text, image, and audio in a simple and intuitive way, taking full advantage of multimodal AI capabilities. So, don't waste time. Explore, create, transform. The future of artificial intelligence is literally in your hands. With just 2 GB of RAM, Gemma 3N shows that the impossible is just a matter of time and innovation. And the next big idea could be yours.